Yeah, well, you missed one out, actually, which is user-defined functions, which are very close to my heart. And Excel functions. So this session is all about Excel functions. And I'm following on from Oz, of course, because I'm going to talk about superhero functions, yay, and evil functions. Not really allowed to mention the word evil, apparently, but anyway, it's going to crop up from time to time. So, go to the next slide. Why won't you go to the next slide? Yep. So, some time back, I wrote a blog post about the indirect function, because I'd come across it a few times with customers, and it was always causing real horrendous problems. So I thought, okay, I think indirect is Excel's most evil function. And then I thought, well, maybe other people don't agree with me. So I put up an online survey and asked people to vote for which functions they thought were the most evil ones and which functions they thought were the best ones, the superhero functions. And of course, I wanted to know why. And the other reason, of course, is because as part of my Fast Excel product, I've written about 100 extra Excel functions, and they sort of fill in the gaps of the Excel functions. Either they run faster than VLOOKUPs, or they do things that the other functions don't do. So I thought maybe I'll find out some more holes in the, in the marketplace if I get the results of this survey. So really, one immediate question springs to mind. What makes a function evil? So it could be it's really slow, bogs down your workbook. It could be it doesn't give me the answer I thought I was going to get, because there's something, not that there's a bug in the function, it just doesn't do what I expect it to do. Or maybe it's so complicated, it's got 26 different parameters, and I can't understand them. Or, I don't know, there's lots of other things it could be. So, these are the kinds of things. Error-prone, hard to understand. You know, actually, I really shouldn't be doing this presentation after the last one, should I? I should have scrapped all this PowerPoint rubbish and gone straight into Excel, because plainly this is an example of a slide that you shouldn't be putting up. Anyway, that's the way I built it. Sorry. Okay, what makes a function a hero? Well, it could be it's very powerful, it does wonderful things, it runs extremely fast, it's easy to understand, I know how to use it, things like that. So this is my list. Okay, powerful, flexible, easy to use, easy to check, robust. Okay, some functions in Excel are very easy to break. You do something like you add another column or move things around, and all of a sudden the function stops working, and you've got to go in and fix it, which is really boring. So that's an example of when something breaks easily, that's an evil kind of function. Of course, quite a lot of functions are actually both evil and heroes. They can be sort of evil superheroes, because, you know, if the function's very powerful, that's good, but it can also be quite evil. So, with great power comes great responsibility. So finally I got to a picture. Yay! Oh, you're right. I do, yeah. I think it's in there somewhere. Anyway, enough of that. So now we want to go back to the real world. Excel. Okay. So this is the, I ran the survey. It's been up there for, I don't know, quite a while. People still occasionally put entries into it. And this is the result. So the evil functions are all grouped in red, and the hero functions are grouped in blue, in green. And after about, I looked at this after about 6 months, you know, so we got enough data in there. And I was absolutely amazed to discover that people thought the most evil function was get pivot data. I mean, why? Now, there's been a few more data added since then, and so now Indirect has just overtaken it, but not by much. You can see that VLOOKUP, for instance, it's an evil hero function and a hero function. A lot of people love VLOOKUP. A lot of people hate VLOOKUP. Everybody hates offset. I actually think it's a great function. Really, really powerful. Maybe that's why it's evil. And there are some things you can do with offset that are very hard to do any other way. Some products, maybe, maybe not. And the one that everybody loves is index match. In fact, well, I guess most of us probably started out with VLOOKUP, you know, as our sort of, when you master VLOOKUP, you think, you know, I've conquered the world of Excel. That's it. And then as time goes on, you discover, well, maybe it's not quite as good as all that. It's sort of got a few limitations. And people tend to migrate towards using index match much more than they do VLOOKUP. If you add the two together, you can see that, in general, a sort of lookup function is the thing that people really think is the powerful stuff in Excel. That's the real hero stuff that they love. And there are a few others. Let's just go back to that get pivot data. And I don't know whether you can see that. Can you read that? Well, anyway, this is the sort of reasons that people gave for why they didn't like get pivot data. So, I feel I have to run my head through a meat grinder to understand the syntax for referencing pivot fields. So bad. I think that's channeling Trump, isn't it, actually? Slightest change makes it break. It's text, not cell references. It always breaks. Pain in the to use. Can't fill down formulas easily. Okay, I mean, these are all good reasons, actually. So, let's actually look at get pivot data. And here I've sort of summarized the good things and the evil things and maybe what you might do to improve things. Some ideas. So the good thing is, well, it works when the pivot table changes shape most of the time. It generates when you click in the pivot. So if I go back to my pivot, no, whoops. I make an equal sign and then go back to my pivots, click in it on the infamous get pivot data. You know, I get this wonderful and totally incomprehensible function. You know, you look at all those parameters and I don't know what they mean. If you try and build that using the function wizard, you go mad. So the only way of really using get pivot data is by using that click method. But on the other hand, when I want to get some other results from it by copying it down, it doesn't work. So what's evil about it? Well, the reference cell's got to be visible. It's got a general pivot table problem. Obviously, you have to refresh the pivot table to make it work. It's slow because it's single-threaded technically. So if you have lots of them, your workbook slows down like mad. It's evil because it's generated when you click in the pivot. Okay, but hang on a minute. That was up there as well. Yeah, sure. Two sides of the same coin. You know, under some circumstances, it's great because it gets rid of all that complicated syntax. In other circumstances, it's terrible because you actually want to make a reference directly into the pivot table. Fortunately, there is a way of changing that behavior. So if we go to options, formulas, I can uncheck get pivot data functions for pivot table reference, which is a bit of a mouthful. And now when I click in the pivots, the same place. Thank you. Why does it always go wrong when you're up here? Yeah, you're right. Okay, right. So let's just do that again. So I'll click equals, go to the survey pivot, hit the right cell, and now I've got a genuine cell reference equals survey pivot B6, and of course when I copy that down, why did that not work? For some reason, I'm in manual calculation mode. I don't know why that happened. Weird. Anyway, okay. I should have been in automatic calculation mode. So there we go. So we can switch it off. And in practice, I mean, that's what I always have it switched off. I never actually use that click in there. In fact, tell you the honest truth, I never actually use get pivot data at all, ever. So if you want to do, but you do want to do something similar to get pivot data, what could you do? Well, you'd have to find an alternative method of doing things. So you could use some ifs, maybe, to build your pivot kind of thing. You could write some VBA to generate the right kind of report that you want. Or you can actually use dynamic arrays. Yay, the new thing. So I borrowed this from Bill Jelen or Yellen. I never know which way he is. Anyway. Jelen, yeah, okay. So we're going to do this with dynamic arrays. So we're going to use 3 formulas to build a dynamic pivot table. It's great stuff. So first of all, what we want to get is a list of all the unique customers going down the side. So new function unique gives me a unique list of all the customers, and I want to sort it. So I embed one function within the other. And that creates this dynamic list. You can see that the top ones are heavily in the formula bar, and the other ones are kind of grayed out. And yeah, if I put something in there, I get this nice hash spill thing because, hey, I'm blocking where the dynamic array wants to go. It comes back again. If I change Apple to, what should we change it to? Oh, no, we want to change it to Microsoft. Google. Okay, Apple disappears and Google's down, yeah, Google's down there. So this is totally dynamic. Now, okay, we haven't got to the pivot table bit yet. I need to do all this, this heading stuff across here. So same thing, we start with the unique of the products, which are down here. Then I sort it, and then I transpose it. So that gives me the list across the top there. And again, this is a dynamic array. So if I put, I don't know, FGH in there, bang, it dynamically changes. And here is the core of the pivot table. It's a SUMIFS function. And so it's a SUMIFS function of the revenue, looking up the customer column in the table, referring to this funny thing, I5 hash. Okay, so this is a new syntax reference in Excel to do with dynamic arrays. So I5 hash means the dynamic array that starts in I5. Okay, so because obviously if you're referring to a dynamic array, its size is going to be changing the whole time. So you can't say, you know, I5 to I10, that wouldn't work. Okay, so this new syntax gets around that, and it's just a shorthand for referring to the dynamic array. And similarly, we're looking at products against J4 hash, which is that thing across there. So wow. So we've built a complete dynamic pivot table in just 3 formulas. I think that's fantastic. And all credit to Bill Jelen for figuring that out, putting it on one of his podcasts. He's got quite a lot of them all about this new dynamic array stuff. I recommend you have a look at them. Okay, so that was a bit of a digression of a way to get around get pivot data, if you like, because I don't need get pivot data anymore because I haven't got a pivot table, and it's dynamic, and I don't need to worry about refreshing it. It automatically refreshes itself. Now, next one up is VLOOKUP, both a hero function and an evil function. So why is that? Well, it's evil because the defaults give the wrong answer. You know, I mean, it's too late for Microsoft to change it. It's a great shame. Back when they brought it out, first of all, it should have defaulted to unsorted exact match rather than this approximate match stuff, because 99.9% of the time you're using VLOOKUP on unsorted data. Wrong default. So this is what happens. You know, I look up the number 9 in this table here, and the answer should be 90, but it gives me 40. It's because I've forgotten to put the false argument in as the third. 1, 2, 3, yeah, false. Final argument, can't count, in VLOOKUP. So what else? I mean, even if you've got the table sorted, it can give you what you consider the wrong answer. So on this second table here, if I look up a 3, it doesn't exist. So I'd kind of like to know that it doesn't exist. But it doesn't tell me that. It just tells me 10. Because that's because of the way the approximate match thing works. Ken, I think, was talking about that. No, not Ken. Who was talking about that earlier on? Oz. Yeah. Anyway, so the other problems with the VLOOKUP, it's very inflexible. It can only work on the first column. It breaks. If I insert a column in between A and B, all my VLOOKUPs stop working because I've got that number 2 in there, which says look at the second column in the table. So yeah, so it looks at the second column in the table, but that isn't what I meant. I put another column in there. I want it to now look at column 3. So exact match on VLOOKUP is pretty slow. If you've got 100,000 rows or 1,000,000 rows, you know, what VLOOKUP exact match does is it starts at the top and goes zzz, looks at each row in turn until it finds something that matches or that doesn't match. So it can be looking at 1,000,000 rows. Not good. Actually, in Office 365, they've implemented a faster VLOOKUP on this exact match thing, and it's really quite magic. It builds itself an index and all that kind of stuff. So if you've got repeated VLOOKUPs, which usually you have, it runs a lot faster in Office 365. It's quite astonishing. There is a magic trick for working with sorted data when you've got missing data in there. I call it the double VLOOKUP trick. And it's a weird case where 2 VLOOKUPs are better than 1. And this is because you have to do it in 2 steps. The first thing you've got to do is to find out whether the VLOOKUP is giving you the right answer. So, can VLOOKUP find the 3 in the look at column? So we do a VLOOKUP of 3 in that column, column number 1. Does it equal 3? If it doesn't, it's missing. If it does match 3, yeah, that thing does exist. So then we can build a double VLOOKUP. First of all, it does the test. If it's true, we get the data from column 2. Otherwise, we return missing. So 3 gives you missing. I make that 4. I get the right answer. So VLOOKUP, yeah, I still actually use VLOOKUP quite a lot because it's easier to use than index match, which we'll come on to next. So, you know, hey, it has its drawbacks, but yeah, I still quite like it. Good things are, it's very fast with sorted data. It's simpler than index match, but on balance, most of the time, we all ought to be using index match, I think. That's my recommendation. So let's look at index match. So the great thing about index match is we can do this nice complicated thing of, first of all, looking down the rows to find the right row number, and then looking across the top to find the right column. So this avoids the breakage problem. If I'm doing that, if I insert another column, it's still going to find the right answer. Okay, so hey, we've defeated one of the problems of VLOOKUP. There are still a couple of problems with it. I mean, for sure. If you're using match, the defaults still give you the wrong answer, so you've got to remember to put that 0 on the end of the match function. And sorted still gives you the wrong answer. Yeah, you can do the double match trick, but that's going to get horrendously complicated by the time you've embedded it inside an index statement. So, don't want to do that. So what's good about it? Well, it's flexible. I can look up any column I like. I'm not restricted just to the first column. I can handle matching both the row and the column, so I'd avoid that breakage problem. It's still fast with sorted data. And, of course, a lot of the time I'm doing multiple VLOOKUPs. I want to get multiple columns out of the table. So I can do one match and then reuse that match, put it in a helper column or something, and reuse it in multiple indexes. So that's, you know, speeds things up a lot, particularly when you're dealing with a lot of data. What else is good? Okay, yeah. If I give it a row number, which is outside the table, I get a hash ref, which is quite good, because that would be an error, and I want to know about it, as opposed to some other functions which don't do that. Now, there are a couple of things about index that don't get used that often. The first one maybe does. So these are what I call the sort of power options on index. So what happens if you use index with a 0 for a row or a column? Who does that? Who uses index with zeros for rows or column? Nobody? Can't believe this. Well, you guys could put your hand up at least. I'm sure you do. Yeah, okay, right. Now, what happens then is it gives you the complete row or the complete column. Or if you said index table, comma, 0, comma, 0, it would give you the whole table. Wouldn't be much point in that, but So here we've got okay, what I've built is a multi-cell array formula entered with Control-Shift-Enter. Who uses array formulas? Who's never used array formulas? A few, right, okay. So, the index A5 to B9, 0, comma 2. So that's saying, give me the complete column, which is the second column. Give me all the rows in that table for the second column. And yeah, so that's what it's done. And if I change that to, for instance, if I change that 2 to be a 1, I'd get the first column. So this is quite a neat trick in a lot of situations. And I can do the same thing, by extracting a complete row as opposed to a complete column. The other really weird use of index is this one. which I've never actually seen anybody use for real life, but it's kind of fun, so might be worth knowing about. It's called the index reference form. And the way it works is, instead of feeding it only one table to look at, you feed it multiple tables, separated by commas, and enclosed in a bracket. So here I've got two. I'm feeding it both this table and this table here. Index, open bracket, A5 to B9, A13 to B17. And I'm telling it to give me all the rows, because that's 0. I'm telling it to give me the second column, that's a 2. And then I've got this additional argument on the end, which is pointing at this switch here, pointing at that cell. So that's 1. If I change that to 2, it gives me the stuff out of the second table. So I could jam a whole set of references in there and have a dynamic switch that controlled which one I was looking up. Quite powerful, I think. Unfortunately, there are a couple of drawbacks to that, which is that all those references must be on the same worksheet, which is really a great shame, because otherwise it would be really cool. I could have stuff on different worksheets and use Index to just dynamically pick between them, but it doesn't work. Anyway, and you've got to remember to enclose the multiple references in brackets, parentheses, I don't know. Anyway, those curly things. Otherwise, it doesn't work. Now, another kind of neat thing about Index is that in the right circumstances, it doesn't return numbers or whatever values or whatever. It actually returns a reference. And so we're all used to using the colon as the bit that separates two references to make a range. And guess what? So I can do the same trick. So the first half can be an ordinary reference, like in this case, A5. And the second half can be an index statement. So this is sum of A5 to wherever index A5, A9, H23, 1 gets to. So if I change the row number, it's going to get to a different place. So it's now going to be summing the first three rows instead of the rest of it. So you can use this technique to build really quite complicated dynamic references. And this is the basis of a technique a lot of people use to build dynamic range names. So who uses dynamic range names? Anybody? A few people, okay. There's two ways of building, but I guess with tables now we've got tables in Excel, the need for dynamic range names has gone away to quite a large extent, because tables do the same thing. You know, they automatically adjust as you add more data in there, okay, which is what we used to use dynamic range names for. But there's still uses for it. Okay, so that was index. Now, let's look at the most evil function of all, indirect. Yeah. Unfortunately, there is a case where using indirect is probably the best option. It really hurts me to admit this. You know, there shouldn't be a good use for indirect. You know, you should never have to use indirect. But unfortunately, I have to admit that sometimes it's a good idea. Yeah, it's bad. So let's suppose we've got multiple worksheets. In this case, I've got one worksheet for each year, 2014, 2015, 2016, and I haven't updated this example recently, quite obviously, because it's not really up to date. Anyway, so, and I want to do a lookup, and I want to choose which year I'm going to use for the to look at, to do the lookup from. So I want to choose the year here, so I could put in 2015 or 2014, and I want the formula to dynamically get me the references from the right sheet. So we do this by constructing an indirect statement. So it's pointing at A5, which is the year, and that gets concatenated to the actual reference, which is A3 to B15. So the indirect, wrapped around all that, generates a reference to the sheet that I want. And then the rest of it's just a standard VLOOKUP. So it's quite hard to build a sensible solution that does this without using indirect. I'll show you a couple of ways you might do it, but they don't always work. The other thing I want to show you is a lot of people said that you needed to use indirect. Yeah, you can't reference a table in a data validation statement. So if I put years down here, which is the name of this table here, it says you can't do that. I don't know why you can't do that. It's just the way it is. So I can fix that by saying equals indirect years. That works. No, it doesn't. What have I got wrong? What have I got wrong, guys? I don't know. Anyway. It worked yesterday. Yeah. Anyway, you don't actually need to do that. But anyway, so you can just put the reference in there. And then the magic thing about that is as I change the number of things in the table, so the number of things in the data validation changes. So I'll put the 2016 back there again. Okay. So what else is evil about indirect? It's slow, it's volatile. So anytime anything in the workbook changes, it recalculates. It's single-threaded, so it's slow calculating anyway. It doesn't work with external workbooks unless they're open. It doesn't adjust when you add, delete, change rows and things. It's a general pain in the backside. When you use trace precedence, you try and debug the formula. It doesn't work. I mean, so trace precedence has showed me the two cells that are directly referenced, but it's completely ignored the indirect because it doesn't know what to do with it. That's a great shame. Of course, there is a solution to that, which is this magic tool. Anyway, we won't go there, which I'm having fun building. Okay. So, how do we fix this? Well, in some circumstances, we can use choose. And choose actually is one of my favorite functions. I think it should be a hero function. But I didn't get to vote in that survey, so it never appeared. And nobody else voted for it. I don't know why. So, instead of using indirect inside the VLOOKUP, we're going to use choose. Choose, as Tony showed us, I think, yeah, needs a number as the first argument, and that controls which of the succeeding things it's going to pick. And those things can be references, they can be defined names, named ranges, they can be formulas, they can be pretty much anything. Okay, it's really quite powerful. And so in this case, I've got named ranges for each of the years, year 2014, 15, and 16. And so as I pick a different year, the choose is going to pick a different one of these. In this case, it's going to pick 2016. And bingo, I've got the right answer. So good news is it's fast, it's not volatile, it is multi-threaded, calculates really, really fast. It's more robust than indirect. It's really powerful, but there are some problems. I mean, you've got to jam all your choices into this formula. Okay, so if you've got sort of 200 things you want to choose from, forget it. It's not going to work. But if you've got sort of 20 or 30 and you're using named ranges, it's quite a good technique. The only other problem is you've got to build it all into the formula in advance. I mean, the nice thing about indirect in this situation is, hey, it's so powerful, it doesn't care. It'll try and do whatever you tell it to do, even if it doesn't exist. So there are limits to this, but where you can use choose instead of indirect for this kind of situation, it's a very good bet. So, oh yeah. This is another dynamic array thing. This is a function that they ought to have with dynamic arrays, but they don't. It's one I built. And it's basically what it does is you feed it lots of references and it stacks them on top one of the other. Okay, so in this case, I fed it those 3 years, 14, 15, and 16, and told it to stack them. So, and if I turn it into a real formula, bang. Okay, so it's taken the data from 3 different sheets, stacked them on top of one another. Now, I mean, it's not a very clever function, this. All it's doing is reading the 3 sheets, and writing them into an array and returning it. So, I mean, you could write it in VBA in about sort of 10 minutes. This one's a bit cleverer because it's an XLL and it's multi-threaded and all that kind of stuff. But anyway, when we get into the world of dynamic arrays, I think this kind of thing will start arriving much more. And with any luck, Microsoft will write some kind of 3D function, for instance, which will do the same kind of thing as this, but you'll feed it, an argument like you can do with a few functions in Excel, where you go sort of sheet 1, colon, sheet 5, exclamation mark, and the reference, and it decodes it all into a single thing. And basically, with something like this, you could do that. So I hope they're going to do something like that, because they've only just started with this dynamic arrays stuff. I mean, there's a lot more functions and things that they could do with it. But I really think dynamic arrays, to me, are the by far the most significant change in Excel in the last, 20, 25 years. Ever since I've been working with Excel. It's really fantastic stuff. What? Oh, God. That's not Excel. Okay. Offset. How am I doing on time? 2 minutes. Oh, right. Okay, what are we going to do? Offset. Some product. Yeah, well, okay. We'll do a little offset. Offset, again, very powerful function. It's very fast, but it's a bit lethal on occasions because it can do things you don't expect. So, really, the best thing used for it, I find, is something like a moving average. So I've got a lot of data, and I want to do a moving average for it, but I want to be able to choose where the start period is and how many columns of data I want to feed into the average function. And doing that with offset is a breeze. I mean, it's really easy, and it works really, really fast. So here we've got an average with an offset built into it, and I've got a start period, so I can change the start period, and I can increase the number of periods. Okay, yeah. Offset again, it's returning an array, so it's a dynamic array because that's what I'm doing. Yet another example of dynamic arrays. So bad news is it's volatile. It doesn't check whether it goes outside the bounds. So if I put in 24 in there, it doesn't know that it was only 12 months of data. It just goes zoomp. And if I tell it to, I could give it a start period that was way outside the range as well. So that's the bad news. Okay, 2 minutes. I'm not going to cover that. So I could spend my last minute on dynamic arrays. Oh, I'm on 0 minutes. Okay, right. I'm not going to do that then. So that's it. There's some wonderful functions in Excel, and there are some really awful functions in Excel, and sometimes they're the same thing. Fantastic. Thank you very much.